kind of understood what it is doing. So, I can give you an overview. So what happens is when you are training a model, it's like those large language models, they are trained on a lot of data, right? And they are not
Yes.
focused onto something in particular, right? So if there
Okay.
is a notebook, Sahil, since you are sharing the screen, if you can go to my
Yeah, yeah,
GitHub, please.
sure.
So see, there is a notebook which says, I think, yeah, non-fine-tuned versus fine-tuned. So you can run
Uh,
that notebook. So it says that when you have a regular model,
yes, sir.
when you have a regular model, and then it cannot really show anything. Like if you can ask it, but it will start giving you a lot of data. So if you scroll down a little bit, I've given some examples over there. Yeah, so hang on, just a little bit. So see, tell me how to train my dog to sit on command. Okay. So see, it started hopefully with a few other tricks. So see, it started giving you a lot of stuff. Okay. So we are
Yes, sir.
asking this to a model. If you go up, so we are asking this to a llama model, I believe. That's what I gave.
Yeah, yeah.
Yeah, stop there. Sorry. Yeah. So llama 2, 4 byte hugging face model. Okay.
Yes,
So
sir.
we are asking this model to check, to give us some answers. So then it's giving me how to train your dog to sit. So it's giving me a lot of this thing, see, lot of nonsense over there. When you go
Yes,
down,
sir. Yeah, yeah.
right?
True.
Yeah, you see, it's giving you a lot of nonsense. Now, because this is not trained to be an instruct or a chat model, to be honest. So
True.
now scroll down. Now we will change it to an instruct. I believe I gave instruct model. Um, yeah, let's check the response of a fine-tuned model. Okay, so see that. Yeah, hang on, hold on, go up a
Okay.
little bit. Yeah, go up. Yeah. So you see there you have a llama. So you have a llama model over there, right? Llama 27B, 7 billion parameters, and it's a chat model. So this chat model is now actually kind of what do I say? Has been trained to work on chats, okay, or it knows how to do a conversation, okay. So then what happens is so we are asking this chat model, and then the nitty-gritty of the things I will start discussing a little bit later. So if you scroll down now, and let's see how this model responds, how to train my dog to sit. So see, it made it a little bit better. So it's now giving you steps, and the steps are making a little bit sense that fine. So this is how you can train your dog to sit, right? So this is what we have to do when we have a large language model, and it will just hallucinate if you ask it something. So what we are doing now is giving it specific data to train on. Okay. So
Yes.
yeah, so we will put so what fine tuning does is now we take that model and we now tune it, because it's a very large model. You cannot do the entire training process, right, by itself. So what happens? We give it a little bit training model, then we freeze some parameters. So freeze freeze some parameters within that model. So like yeah, so we would try to freeze some layers of a transformer. Okay. So that's what we are trying to do in the first step is doing Q LoRa. So Q LoRa actually freezes. So in a very high level sense, yeah, if you go to, yeah, so probably the Q LoRa. Yeah. So two few things we are doing because we have to train the model within Google T4. So what we are doing is we are using an accelerator. So it's a Hugging Face accelerator, Q LoRa. Uh, yeah, so it's called a low rank adapter. So I think I mentioned a little bit on Q LoRa over there. then we try to quantize the model. So lower precisions like 4-bit, 18-bit. So the number values or the arrays that it generates are not a really higher bit, which will take more space, right? So the number of bits actually, the more the number of bits you get, the more you get more, you have to store that memory in the RAM, right? So that's the reason you use bit and byte, okay? And then this one is actually using a small transformer data set from the Hugging Face. Okay? And if you scroll down a little bit, so I'll just explain this notebook a little bit. Yeah, so here, yeah, hold on over there. So this is a data set, okay? So this is, so if you create, so this is free data set, but you can also go into Hugging Face and create, what is that? An account for
Okay.
yourself. So
Um,
you can, you created that, right? Okay.
I have a doubt. Like, the API keys you're making in the Hugging Face,
Yeah.
it should be every time of write only, right? The write mode. Or
Uh,
because
so,
the problem is that whenever I'm like
uh-huh.
when I was trying like before the Unsloth one, I was trying to do the Mistral 7B model, the
Mm-hmm.
other ones. When I was putting the Hugging Face API key, for some
Yeah.
reason it couldn't identify the API key. So that's
Okay.
why I was having a doubt on
Yeah.
that.
So you do one thing. It is my API key. So
Yeah, yeah.
probably,
I like see I made an suppose if I had made an API key once ago. So like here I made an API key,
mm-hmm.
right? Yeah, so if I am accessing this, like the permission is right? It should be a
Yeah.
right only, right? Yeah, so suppose
Yeah.
if I'm
Yeah.
keeping in my supposing like over here, uh like if I'm replacing your API key with my API key,
Mm-hmm.
for some reason it doesn't work. And it tells that the 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 CPU or the GPU is not allowing the API key to, continue the thing.
Okay.
So
So can you open this?
Yes,
I
ma'am.
think there is a
For
problem.
me
Okay.
also.
Oh,
ma'am, the
for you
same
also?
error, Siddharth
Mm-hmm.
also had the issue. So that's
Okay.
what I just wanted
Okay.
to.
For me, it's
Open.
showing like it's not connecting to the Hugging Face.
Okay. Okay. So open your. Can you open it on full app? Let me check.
Uh, so this is the unslot
Yeah,
one. This
and
was
see there
14.
is a key. There's a key. Do you see the key? At the left hand side, there's a key.
Yeah.
Yeah, click on the key. The key icon. The key
Oh,
icon at the
yeah. Okay,
left
okay.
hand side. Okay. And what is that project? What is
That is
that?
the API key, which was there before. So
There
like,
before. Okay. Yeah. So you can now delete this. Delete it.
fine.
Yeah. And now add a new secret. Okay. Put HF token and then your value. Yeah, write HF token and then the value. And let's see, you do this.
One sec.
Okay, I'll put it in chat.
Oh, okay.
Yeah, so now see in the chat, take that code, part of the code from the chat.
I see the chat for something.
Yeah, in the chat. So in this
But
chat, Teams
I
chat.
can't. Oh,
Yeah, so see there's a chat. Go at the
yeah.
left. Yeah. Okay, copy that. Copy that and we have to just remove two lines.
What's the point here?
Yeah. So now pip install, remove the first line. You don't need a WANB right now. Yeah, and keep that. Yeah, import. Yeah, so import WANB, you can remove it. Okay. So then you can, instead of WB token, put it as HF token here, HF token. And then in WANB, put it at HF token. Okay. Yeah, let's see. Yeah, HF token. Yeah, that's fine. Yeah. Okay. And then maybe print HF token. Let's see if that's working. I'm also checking my Hugging Face at the same time.
Will it comment now? So like yeah, I'm getting this.
What are you getting?
I'm getting that HF token is
Yeah, grant access. Grant access. Yeah, run it
yes.
again.
Okay. Yeah. Yes, ma'am. So
Okay. And what's happening now? Okay, it's
it
printing that
print with the
value.
yeah, it's working. It's working.
Okay.
Actually, it
And
was not printing also before, so yeah, it is working.
okay. And where did you use this in your the HF token?
In so wait, in Unslot I had used yours since it was not
Yeah.
working mine. So here was a token. The token
Yeah,
was
you can
here.
put this HF token instead. Yeah, put HF token, your token, and we can check what's going on.
Sorry.
Yeah.
Ma'am,
Yeah.
I wanted to share like what like we can do. Like
Sorry, what? I didn't get it. What
uh,
is that?
ma'am, like the a better like a potential improvements like we can do in the code.
Yeah, so the potential improvements that you can first of all do is basically use more data. Okay.
Yeah,
So
yeah.
go,
First is that, yeah, correct.
yeah. So now the problem is, so the problem is with this data that is provided, or with the T4, this is the maximum almost you can go. So what you can test right now is, where is the data? Load the data. Where are you loading the data? Yeah.
Down.
Yeah.
Like
So this
it's
is here. Yeah. So this is
um
the
yeah,
DPO model. Okay. So this is
yeah.
DPO. So what is DPO? It means direct preference optimization, of course, right? So DPO model, you need two models basically. So when we there's a reference model and there is a regular model. Okay. So what Onslaught did is they use the same model because they are trying to not use that memory. So if you go to T4 at the when where you see the T4, and there you can have managed session. So while you are training, you can see when it's shooting up. So if it's really going out of memory, then that's where you have to stop. So
Yes,
go
ma'am.
to T4 RAM. Go over to T4 RAM. No, at the top. See you T4 RAM and disk at the right hand.
Yeah.
Okay. Okay. So see, how much GPU RAM you have? It's 15 GB
30,
max.
yeah,
Okay,
15
and it's
GB.
almost it's almost taking your memory. Okay. So the more number of computations that it will start doing, is it will run out of memory. So when you are increasing the data size, so where is the
Yeah.
data? Yeah,
The data is down.
yeah. So let's look at the data.
Now, like, so even this also, like the training, this is the training part.
Yeah, so this is training part, that's fine. So we trained it for smaller intervals, but go to the data. I wanted to show the data. Oh, apply. So this is chat template. Okay. Yeah, stop here. I think this is the one. So stop here. Go up a little bit. Yeah, raw data. Uh, should be somewhere, should be written Hugging Face. And this is the, okay, I'll also check.
I'm here.
Found it? Yeah, so see, we only took a small sample of data, 0.5% sampled, okay.
I'm
A
like, yeah,
very
so,
small, yeah.
yeah,
So
if we
now
take
if
a
you
sun,
take, yeah, so now what you can do is, you can, yeah, so start taking a larger sample size. Yeah, so put it there, put it like that, but make it like instead of zero point 0.5, yeah, 5.0, yeah, yeah, something like that, 5.0, yeah. And you can start, yeah, you can test it later on, okay. So let me just, yeah, so you can test it, and then you can also check how your data set is shooting up over there, okay. Or sorry, not the data set, how your GPU usage is, when is your GPU usage stopping. So T-Food is a like a free version, or like you can also use the in the free version of Google Colab, you can use T4, but it will have its limitation. So you can do this experiment and see what is going on. And then the other experiment that you can do is taking the number of, increasing the number of batch size. So do you have a batch size somewhere? Can you search a batch size? So ideally you should have a batch size which is between 16 to 34. So I think we have a batch size here. Search batch size, Control F and search batch size. Not batch size, batch. So how many batches are we training? BATCH.
yeah,
Yeah. So what's the batch size? Laura, answer which to a larger batch sizes. Okay. That is not choose any number. Okay. So batch size is fine. It seems batch size is okay. Batch size we did choose 64. We can try it with 128. Yeah, is it no, just 1 minute. Okay. Yeah. So per device, so if you go to DPO trainer, so I think that's where you can test few steps. So can you search DPO trainer? Yeah, over there. See, per device trained batch size is 2. Yeah, it was there. Yeah, so DPO trainer. Yeah, search DPO. Yeah, yes. Yeah, and go down, scroll down. Yeah, I can see that actually. Hang on, over there. Yeah. So per device train batch size is equals to 2 and gradient accumulation step that we for now you can change this to a higher number. That per device train batch size, you can change this to a higher number. So you see that DPU config. No, at the so for DPU config, the first one.
Uh, yeah, DP configuration.
Yeah. So this one you can change. You can experiment with this. And
Okay.
also the gradient accumulation step. Oh, that is fine, that it will just accumulate. But you can change the batch size and you can try with that. You need to train with at least 50 epoch is a good number. Okay. So 50, no, this not this. So batch sizes usually would be 8,
Uh,
16, 32. Yeah.
yeah.
Okay. Yeah. Yeah, so you can put that and then you can try with running it. So number of epochs, it's now 3.
Yes.
You see that? Yeah, number of epochs is 3.
Yes.
Yeah, so you can increase that epoch number to 100 and see how it is behaving with your T4. First, that's your test. So
Okay.
these are the all the things. So whenever you want to improve, like in a deep learning model, so the best thing to go about is more data. Then you can increase the batch size. So these are all your hyperparameter tuning, and of course increasing your epoch size. Okay, so training it for more number of epochs. Then there are few more hyperparameters like learning rate. So learning rate is 5e6 and this you can, so this is a very low learning rate. It starts with low learning rate and then LR schedule type. So what is that? Big, so you see Euler schedule type is linear. So as your training progresses, your linear schedule, so the Euler value increases. Okay, so learning rate value gradually increases. So in the beginning, it's a very small learning rate, and then it starts increasing linearly. So you can also try this as steps or exponential. So these are some things. So how you how you want to check your model is now doing a lot of hyperparameter tuning. Okay. So having said that, I'd like to share. Yeah. So try with this and send it out to me, and we can then discuss about this. Okay. So I'll share my screen and I'll give you a small. Even though the notebook is little bit not running right now, so let me just show you, and I'm in the process of fixing it. But let me still show you one of the ways of how you do an hyperparameter tuning. Okay. Okay.
And we can also add like what's it called? Uh, like data loading failures or
Data what?
loading failures, like
What
an
do you
error,
mean by that?
like error handling, basically.
Yeah, I don't understand what you are asking about error handling. So what happens is whenever you are training a model, it's called hyperparameter tuning. Okay.
Yes,
So
sir.
let
But
me
like like
open.
if GPU like suppose like if there is GPU memory issues,
Yeah.
so we can just like add a what's it called? Yeah, a try except block and all, so that
Yeah. So GPU memory issues when this happens. So what is the next step is you for for a commercial project you will be not using one GPU. So for
yeah.
a commercial project you will be at least using 2 or 4 GPUs in this kind of training exercise. Okay, and it is called there are few ways to use this. It's one of them is called deep speed. So deep speed is a
Correct.
configuration that you would use, not deep seek, deep speed. Okay.
Yes, yes, yes.
Yeah, so deep speed is a configuration that you will use to configure. So I think I have also given it in my note, repo. So it's called deep speed. So you configure it to use more number of so it's parallelizing your uh, matrix calculation. So it will calculate the part of chunks of matrix for in your different GPUs. Okay, so wherever matrix calculations are happening, PyTorch is automatically distributing it within those GPUs. So that is not possible on Colab because Colab only gives you access to one. But there is a paid version which is called A100. So in a paid version, this GPU size is 48 GB. So you can still work with that 48 GB, but sometimes that also runs out of space. Okay. So those are your GPU solutions. When you run into these troubles, so you need to use parallel GPUs, multiple GPUs in that scenario.
Yes,
Got it? Yeah.
yes.
So let me show you. Let's see if I can show you this. So I gave a small. Oh, yeah. So the other one that you have to use is called widths and biases, right? So so if you see all those the all the hyperparameter tuning that I mentioned actually will create a lot of models, right? So you see these are models that you are created. So for a DPO model, our so our model has to learn like so our main goal is it decreasing my loss function or what, right? So this is giving you an example of how your training rate is approaching. So I trained it up to 200 steps, let's say. Then how did this training rate started falling, right? Or how is the train reward margin and train rejected margin, these started working. So if your training loss started decreasing and it started understanding which is rejected and which is accepted, then that's a good model. So that's how your model that you can understand. So this is what you will you when you are trying to. So this model, for example, didn't do much. It just stopped. It failed at some point. So you always have a dashboard or a logging device or logging tool like weights and biases, okay, to check how your model failed or how your model performed over your training steps. Okay, so over all your training. So this is one. Mm, you can also have all the runs. So see, it will say that which one crashed, which one finished, right? So these one crashed. So we can probably investigate why it started crashing, okay, or what happened to this, okay. Then you start seeing that these were the parameters that you start logging. Uh, yeah, so all the parameters that you were logging, or yeah. So how did those behave and all? Okay, overview. Go to overview. So overview gives you what were the configurations you did. Okay. So this is so we had like train epoch 0.32, it didn't go much, or so train runtime, train loss. So this is a very important factor, how your loss behaved. So So these are summary statistics. Train underscore loss is something we probably define. How did it behave? Okay. And then how do you do this? So I will share this by today or tomorrow. I'm trying to make a notebook for you guys. So how do you actually do this? So other than that, a Onslaught is basically a software by itself. So they provided their own training module. But in general usage, you would basically start using weights and biases or Comet. I prefer weights and biases. In our company, we always prefer weights and biases. So here you would, let me show you. Yeah. So here you will actually do a configuration. So you will mention, so this is a RNN model training. So you will mention what are your learning rates, what values do you want to use, what is your batch size, sequence length you want to use, what is your epoch size, if any class width, so do you want to use some class width. And then you configure your hyperparameter tuning model with a project. So you can name the project. So you name the project and then you can say that I need max of 5 counts. So I don't need, so these parameters when they are combining with each other, say they might get multiplied, right? So they're permuted and they get combined to make a bigger data set or bigger number of hyperparameter space. Okay. So you might say that I don't need that, I need 5. Okay. So these are some tuning parameters that you can do in weights and biases. So right now it's failing, but I'm figuring out why it failed anyways. So you can actually check that this is how it will start showing up. So it will show in a very similar way in your space. Okay. So yeah, and I wanted to show another thing. So you then what you can do is then you put all these initial sorry all these parameters. So a good way is to test your optimizer. So another way I think for fine tuning it's fine. I think the optimizer that is in default used over there is okay. But for computer vision models or for RNNs, we start testing different optimizers, Adam, SGD, AdaGrad. So you can mention those over here. Then you can mention the learning rate. And the way your model always trains is you train the model, put the model in training state, then optimizer zero grad. So if some of you have done that torch notebook, then the torch notebook actually mentions what is zero grad. So you first when you are back propagation, so I discussed back propagation last time, right? So when you are back propagating, you first make it 0, start from 0, and then you start computing on your gradients. Okay. Um, or put the optimizer value to 0. Everything is 0, and then you start doing the loss dot backward. So you might not see this in your DPU trainer, but this is provided by Hugging Face. So if you check the Hugging Face code or Hugging Face's actual code, so they have done all these things at the back. Okay. So Hugging Face has made a library for us, so we don't have to worry about all these things over there. Okay. So it is at the back of it, it's calculating, so taking this criteria. So here, because we are using a cross entropy loss, so there could be different losses. Okay. Mean square error, cross entropy, dice loss, the different losses over there. So you can mention the loss function. I don't remember what was in the notebook, so we can check that. But yeah, so now then you are trying to, our goal basically would always remain is minimizing the loss between a training and a validation set. Okay. So if we can minimize that loss, and the loss should decrease with as you start training. So as you start training, you can Sahil, right? So you can actually check how is your loss behaving. So plot a graph like this from the onslaught. You can try with that onslaught, and once it has given you those values, You can plot a graph and check how is it behaving. Then you can also, I think I didn't use a validation set there. You can start putting a validation set back to it. Okay. So that way you can, these are all the things that you can start testing out. So this is, so when you, generally when you do a deep learning, this is the best way to go about, because one training is not the answer. So you need to start training a lot of models, keep training a lot of models. Okay. Okay. So here, yeah, so yeah, I will put this and you guys can take a look at this RNN training, but let me
I
stop
mean, the
sharing.
previous
Yeah,
class we had given us thing, right? The GitHub for the classes.
sorry.
In the previous class, you had given us the notebook, like
Yeah, so one notebook I gave. Yeah, so I did put this notebook, but this is not, this was
yeah,
for me to explain. Okay. So I will
yeah,
explain, yeah, so I will now go over explaining a little bit about RNNs, and you guys can, in the meantime, just I will explain and put it over there. So you can just check my notebook and do your own analysis. So no need to complete this notebook. Um, Next week, me and Vishal are thinking that Vishal will do some interview kind of things, right?
Yeah. We can. We'll do like a mock kind of interview.
Yeah, so we'll give you an
Yes, so that you guys
yeah,
also get used to that little bit.
yeah,
Yeah.
yeah. So because we are hoping that all of you who are joining in this meeting are more interested in going into as a machine learning engineer and all. So we will do some data structure DS, very simple DS questions, and how you face an interview, how you can explain. So what, uh, like in interview, you'll be given some questions like, explain me what backpropagation does with optimizers, right? So these are few things. How much did you learn? Right? So we will do some mock interviews like that. So it's not anything. So just to give you an idea, but yeah, and I will
Yeah,
put this
don't panic
notebook.
about it. It's more of a, practice and giving you a kind of a flavor of what kind of situations we'll face in future. Yeah.
sure, sir.
Okay. And so yeah, sorry, I'm just talking a lot. I need a little bit rest. Just give me 4 or 5 minutes. Vishal, you can do some talking in between. I'll just take some water
Yeah,
in
yeah,
the.
sure. So, okay, I think you who has LinkedIn profile? Anyone has LinkedIn profile?
I
All of you
have,
have
sir.
LinkedIn profile.
Yes, everybody
You have,
has.
so please, can you log into your LinkedIn and share your screen? Are you on your laptop? Yeah, so I'll just help you list this internship on your LinkedIn.
Yeah.
Yeah. So whoever doesn't have LinkedIn profile can make the LinkedIn profile. We'll do the rest next week. So today we can do for whoever has that profile. Okay. So you're sharing Sahil. Yeah. Okay. Okay. So Sahil, see the photo you are putting, put your own picture. Okay. This is LinkedIn is
So
like
like,
your own digital resume.
yes, yes, sir. Sir, actually, I will be doing like after my exams and all. I don't have time.
Yeah, that's fine. I'm just giving you first impression problem.
Yes, yes.
Okay. Now you can click on your name only, Sahil Parik.
Yeah, yeah.
Yeah, and then in the pencil top right, there is a pencil kind of edit button. Yeah. Okay, go down. Oh, yeah, okay, you have not added your education also, is it?
Sir, like I will be doing it after my exams because I have a lot of things to add. So like, once and all
Okay,
for all,
okay,
I'll be doing
okay,
it.
okay. Education and current position. Add new position. So I'll give you one thing from our side then. In the title, just write junior AI intern. AI intern. Yeah, that's fine. That's fine. Yeah, that's fine. Employment type internship. Company live AI, LIVE AI. Yeah, I think that one. Yeah. correct? And start date, you can put February 2025. Okay, and they don't put location, put ASSEN, ASEN, ASSEN. Yeah, that one. Netherlands. Huh. Location type, remote. Description, you can put we are learning, uh, we are implementing a basic AI project, a basic AI project to kickstart our AI career. You can change this slightly. I'm just giving you like a skeleton kind of thing to
Startup.
kickstart my AI career. Career. Yeah. Okay. Yeah. You can,
Okay.
profile headline. Yeah, you can just save. Yeah, that's it. So Tanishta, you can resume.
Yeah, sure. I can probably do that. Yeah.
Yeah. Yeah, you can do a post also next. Yeah, next post. So, see everyone, just for your information, LinkedIn is like your digital resume. Don't ignore it. I'll rather suggest everyone to use LinkedIn more than Insta, but maybe that's not practical for young generations these days. But give like 1 hour to LinkedIn at least, half an hour to 1 hour every day. That will help you. And what you do in this 1 hour, half an hour, is basically find connections, relevant connections, who are like your senior, like your batchmates, like your people you are looking up to. So these people can act as your mentors, as your guide in a digital format and things like that. So it will be a good. Every day you can send almost 10 to 20 connection requests. So you cannot send more than 100 requests a week, kind of. So that's like the limitation. So make use of your every day. Every day if you send, every week if you send 100, right? So there are 52 weeks. So 52 weeks into 100, 5200 connections you can send actually in a year. Obviously, not everyone will accept. Maybe half of them or one third will them, or even one fifth of them will accept. But still, a meaningful number of networking opportunities you will get. So okay, Tanishta, you can resume.
Yeah, sure. So I will give a small intro today about sequence modeling. Okay. So so all the time we were last time we kind of discussed multi-layer perceptron, right? So this didn't had any time factor to it, right? So you had some state, and then you train that state for one epoch and or for a epoch, and then you back propagated and updated the value, and then just did those image kind of classifications, right? So you did those digit classifications, right? So now there would be many situations where you would have sequence, right? So sequence in the sense that you can have a very small example here, that this is a ball or this is a dot, right? And you have to predict where is it going next, right? In which direction will it go next? So with this information, you cannot do anything, right? So it's just one dot is only given to you. So you need more context or more information for that. So how did it behave in the past? So that based on that, you will try to understand how it will behave in the future. So same like this is a very good example of your stock price, right? Did your stock price behave in the past? Based on that, uh, you can predict how it will behave in the future. So there are many different time series models, but one of them could be the sequence model. So RNNs are or LSTM. Actually, it's called LSTM, long short-term memory model. These are the ones that used to be used earlier, and now again better models are coming in. But even now, if you use any sequence model, your stock prices analysis will be quite good with this kind of model. However, these models actually remained the what do you say, the backbone for your large language models. So when before the discovery or before people started using more of transformers, so people were using more of the RNN. So now, why RNN? So now, if I know how this image or how this dot behaved in the past. So let's say this is at t equals to 0, and then it's you have t minus n, then t minus n minus 1, and then it just goes like this and goes to t equals to 0. And then it's easier for you to predict how it started working or how it worked in the past, right? So where it will go next. So if you know that it was kind of going like this, then it will basically be following this linear progression. Otherwise, it will just stop over. You wouldn't be able to predict anything. Okay. So given the linear progression, you can just say that fine. It probably might be moving in that direction. Okay. I think I have to download this file. Okay. I let it download. So this is sequence. So a sequence like the example that I'm putting together for you guys is music generation. So that is also a sequence, right? Anything that you can think of, it has a time kind of factor to it, you can think of it as a sequence, right? So running, stock prediction, ECG report, even for Earth, like how is the climate going to how is the climate going to be next day or in 1 hour, right? So those are also, everything is sequence. And now you can also think your language to be a sequence, right? So why do you think language is also a sequence? So if I'm writing a sentence, why do you think language would be a sequence? Any clue? Any guess?
Like we can understand the previous sentences and predict the next word.
Yeah, right. So basically, your what any language model is trying to do is predict the next character or next token. So we'll discuss about tokens. So all these language models, just you have to remember when you were doing this exercise also on fine tuning models, we were tokenizing the sentences. Okay, I will digress a little bit because I just probably you guys got it, but I'll just reiterate this a little bit. Token. So tokens are not really those words, right? So let's say the guy is running, right? So run could be um a word, and then ing is another token. So run could be an token, and ing could be another token. Let me sorry, one. Go to PowerPoint a little bit. So when you guys can go back a little bit and just check your tokens. How the tokens were generated. So, okay. So run. Okay. So I am running. So I am running. So running. So these could be. So run can have a value. So at the end of the sorry, and then you can have that this is like a starting value. EOS. This is end of sentence. Sorry. EOS. Okay. So this is what my sentence is. So when so my so yeah, so the next thing is predicting a token. So probably I am running. So in the I am running, I want to predict this ing token. Okay, so when since you guys are now all deep learning kind of aspirants for that, when you talk about this, you would say we want to predict the next token, not the next word, like so whenever a language model is trying to work on, so it's trying to say is it ing or it is EOS. Did it do I have like, do I extend the sentence or do I not extend the sentence, right? So I am run ing. So it will know that it has to put ing at the end. Okay. So yeah, so that's basically you are right that this is the reason it's a sequence, and this You are now trying to predict the next token. Okay. Okay. So just giving you a small idea here. So sequence modeling, so this is, you can have a sentiment classification, right? So you are given Twitter data, for example, and you do, so you are given a lot of word or sentences, and you, from there you can analyze your, classify your, what is that? Your, sorry, analyze your sentiment, right? So this is many to one, one to many. You can give your GPT, chat GPT, this image and ask it, give me some caption. So it will give one to many captions, right? Then you can do machine translation. So machine translation is basically English to French or English to Hindi or anything like that, right? So those are, you are giving many words and it's predicting many words back, right? So that's, these are how you can have it. So, and this guy you can not used much, but this is like a binary classification. So will I pass the class? Students, yes or no, right? So one to one, will I pass? Yes or no. One to one can be also there, but I would say not done much. But you will be focusing more of these kind of situations nowadays more. Okay. Now, this you guys, I think if whoever done the notebook a little bit, guy kind of got it. The perceptron, right? So I was telling you about an activation function, right? So taking all the values from the previous layers, combining it with weights and biases, you are getting the new value, right? And the new predicted value. So z and then is a function of g of x. So it's a function value, and y hat is your predicted value. So predicting based on all these weights. So it's kind of a linear, just a linear algebra, right? So what is this called? Always remember this is called your feed forward. Okay. So just to recap, so this is whenever you are going from the uh, from from your input and getting an output, that's a feed forward. When you are going back, it's called a back propagation. Okay. So x of t, yeah. Now this is how your feed forward neural networks are working, right? So it's one state, right? So at a given state of, or at a given so sorry, not even a time. There is no time actually. So x is in R of m. So x is within a set, and yt is within a set, but there is no time connection between them, right? So how you can modify this is you can put an xt and then have a layer of hidden layers over here. So just think of last week's simple example. You had some hidden layers, and then hidden layers are giving you some predictions, right? Now, these hidden layers, you can think of a lot of hidden layers now. So I can have an x at a position of 0. So at the time 0, I have x and it's given me, I have some hidden layers and it's giving me an yt, right? At x equals to 0, x equals to 1, I have some hidden, again, some input with the hidden layers, and then I also can check a y of 1 hat at that particular state. So these are now going in a time step order, right? So now I have converted my perceptron to a some time step, time kind of functionality, right? So now looking into this diagram, what do you think is missing? Any guess? So I have different time steps, but what do you think is missing over here?
Maybe the past inputs.
Yeah, so the past input, you can also think this as a present state, and this can become your past input, right? So even this could be a present state. You can think of those as your past inputs too. Okay, so that's not the right answer I'm looking for. Can anyone can guess more a little bit?
We like specify something.
Yeah, so
But
yeah, you have to specify something. So see, that the problem that we are facing right now is all our states are individual states, right? And all our states are becoming individual states, but they are not connected to each other. So all these layers, so this one input at x0 gives you a y0 output, y hat y0 hat output, things like that. But it is not connected to each other. Okay. So that's the reason we have to now connect all these hidden states together. So this is where the connection comes in. So this is how we make a connection. So this holds the past memory. So if I'm thinking this is the present one, so h minus 1, so that is h of 1 is my past memory. So the past memory has to be carried forward to your present memory, right? So this is how you make that connection. Okay, so this is a very visualistic term. It's a function of input xt of that particular time step into h of t minus 1, that's the past memory. Okay. So this is so in a very general term or in a rolled in term, it's called more rolled in, but you don't have to remember that. That's okay. So you have yt, xt, ht, and then so this arrow thing over here is it's called a recurrent cell. Okay. So this hidden layer do need information from this layer, right? So it has to go back and get the information from this layer and this layer too, right? So it this every hidden layer in this sequence need information uh, from the hidden layers which are at the past, right? So a reference to the past memory. Right. Okay. So these are called then called the recurrent cell, and this kind of network is called the recurrent neural network. So now you can see the significance that why you need to understand the past kind of values or past context that the large language models are also trying to test, right? So you can apply a recurrent information. So cell HT, so that is a memory. So the present memory HT equals to a function of the input state and then an older state. Okay, so T minus 1. So this is how your recurrent neural networks are defined. If it was a regular neural network which didn't have that time concept, you wouldn't be putting HT1. Okay. So you just it will be a function of the input. Okay, the hidden state will be just a function of input, but because that time thing is coming in, so the cell state is basically a function of input and old state. Okay, so yeah. So then how do I define an RNN? So for each word in a sentence, we are predicting we are doing a prediction of YT. So we are doing this YT prediction based and it's so my RNN is taking in a word and a previous hidden state, and it's actually calculating and giving back my a prediction and HT. So this was HT minus 1 and it is giving back HT and YT. Okay. If you are trying to now write it in terms of some pseudocode. So initial hidden state was 0, 0, because this is the hidden state again. Here we are going to find these hidden states. These hidden states also you have to think have a width and the biases, right? So these are things that we also have to calculate in. And hidden state is also defined with a neuron by itself, right? So anyway, so this equation over here is basically this over here. Okay. So it's a function of input and older state. Okay. Yeah. So yeah. So here the love recurrent neural. That's the sentence that you have given because and if it's a trained model, then it understands that you have to the next word prediction it has to give is network. So I love recurrent neural network. Okay. So the probability, so this is also called a probability function, right? So when you are training language model, not RNN really, but a language model, you can also set a temperature called temperature. Okay, you can try this in Hugging, no, not Hugging Face, OpenAI Playground. If you check OpenAI Playground, you can set a temperature. Or probably if you are working with DeepSeek, you can also set a temperature. But OpenAI Playground, I know better. So you can set a temperature. So the temperature will tell you, uh, do I input only the values that have a very high probability, like close to 1, or do I also give you some options which has some probability close to bit above zero point 0.5, okay, let's say. So probably you are not looking for that. You are not looking for a network. So you can say a recurring neural system. Probably you are looking for a system, and the system, the probability of getting a system is around let's say point little bit greater than zero point 0.5. Okay, these you cannot. So RNN cannot do that, but really all these language models these days can do that. So you can set up a temperature, and that's what it is trying to predict. Okay. Okay. So let me yeah. So this RNN state update and output. So you give an input vector, and then tan H. Okay. As I was mentioning, right? So every one of these hidden state will have a weight, like a weight matrix. So WHHT, WXHT. Okay. So this is with the previous hidden state, and this is calculating with the present XT. So this is the relation between your input and the hidden state, the present hidden state. Okay, and can anyone mention why this tan H function we are using? So we are calculating a hidden state, and then I use this tan H here. Why? Any guess? So
Get
this
the
is, yeah, go
answer
ahead.
from
Mhm.
-1 to 1.
Yeah, right. So you have to scale it between mine. Actually, it's 0 to 1. Yeah. So we'll tan H actually goes from -1 to 1. That's true. So we are scaling it. But generally in these RNNs or LSTMs, you use ReLU, which will scale it between 0 and 1. Okay, but for writing purpose, this is fine to scale it between -1 to 1. Okay, and this is how your output looks like. So output also has HYT, HT. So that's these are all the weight matrices that we have to tune now, right? So with all epochs that you are training, these weight values are going to be trained with all this relation, right? Okay. So this is rolled and unrolled relation. Okay.
So session is over now, is it? Or did I miss something? Tanishta has left.
So
I guess the
Baba
session is over.
he left in
Ma'am has
between.
left, is it?
Yeah.
Oh, okay, okay. Just wait for a few minutes. Maybe she has some glitch, then she'll join back.
Yeah.
Okay. I was just wondering what happened. Yeah, just wait for a few minutes, please. Yeah.
Sure.
Maybe she has her laptop discharge or network issue or something. Yeah. If she doesn't come back in 5 minutes, then we'll end the session. Okay, meanwhile, if anyone else want to update their LinkedIn, they can share the screen if you want.
Yes, sir. Can I share the screen, sir?
Yes, yes, please. Let's make use
Okay,
of the
sir.
time.
So is it visible, sir?
Just a sec. Yes. So you can go to your profile. Yeah, okay. On the pencil at the top left, or yeah,
Yes, sir.
that pencil, yeah, that one. You have the premium profile. Okay, go down current position.
Yes, sir.
Okay, you have put some position already. Okay, add new position.
Add new position.
Junior AI intern. Employment type internship. Live AI. Live AI. There's no space between live and AI. Yeah, that first one. Okay, month February 2025. Okay. Location ASSEN ASEN EN. Yeah, yeah, first one. Netherlands. Just next to Amsterdam, actually. Yeah, so just like Delhi, Noida kind of. Location type remote. Yeah, here description you write. So here we are doing a Kickstart project in AI. Yeah, here we are doing a big project in AI to kickstart our AI career. Yeah, like that. You can rephrase if you want later. AI career options. CAREER, not courier. CAREER. Yeah, double ER. Yeah, option. Okay, save. Yeah, you can next. You can post this post.
Okay, thank you, sir. Sir, so actually, Sadaf Fatma has shared me this website link. So I wanted to know more about this session. So what's going on? Because it's my first session for.
Today you joined the first time. Okay, okay, okay. So I think have to do the rolling then, because there are 4 sessions. Okay, and I think you joined like in the middle. So this will be like a. So you have done the course or not yet? The LLM.
No, sir. She shared me this website webinar link, and she told that get more information from Vishal, sir.
Okay, 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 fine. So you can. I'll just let me just put number to you also in the chat box. I'm typing. Okay. Yeah. So just note this number 9748112438 and WhatsApp me once. I'll add you to the group of Saturday's session. So you can join either from next or next to next. I think next to next we'll start the new session again. So next one we are finishing with like the group wise, like 4 sessions a group we are doing. Okay. Yeah. Just yeah. Okay, I got your WhatsApp. Okay. Sure. Sorry. Okay. Anyone else want to update their LinkedIn, or we can do it next week maybe. I think it's 10:20 now. I think Testa is not joining. I think. Okay. Yeah. Then you want me to end it. Okay then. So see you guys next Saturday. And Vijit, I think I'll let you know. I think maybe you can join not but next to next or something, or maybe we'll invite you in one of the session as a kickstart or something. Okay.
Okay, sir. Okay, sir.
Okay. Everyone, have a good night. Take care. Bye.
Thank you, sir.
Good. Thank you.
Thank you, sir.
You all can leave. Thank you.
Thank you, sir.